Hi, and welcome to the next episode of Qt QML tutorial. In the previous episodes, you had the pleasure of participating in the development of app like Demystify. However, at that point, every song was hard-coded. Today, in this episode, we'll improve the app by adding a playlist with songs using C++ models. My name is Lukas Kosiński. I am the CEO of SciStudio, QML consulting company. We help our customers achieve their objectives by providing them with skilled Qt developers. So today we will dive into powerful model view pattern of Qt framework. You will explore how this mechanism, this system, empowers developers by allowing them to separate the data and presentation layers. Let's go. Before we start, let's talk about what the model view pattern system in Qt actually is. It's a bit like MFC, model view controller pattern, but still it's a bit different. Models represent data sources, while views define how the data should be presented to the user. The separation of data and presentation allows more modular and flexible design architecture. In Qt, models can get data from a variety of sources, including C++ models, XML, JSON, database, dynamic data fetched from the network, and many other sources. Once a model is defined, it can be bound to a view component, which automatically updates whenever the underlying data changes. This enables real-time updates and synchronization between the user interface and the data source. The model view pattern supports the separation of UI and business logic, which results in more effective workflow and clean project architecture. With QML's simple syntax, programmers may concentrate on developing the user interface while handling the underlying data and logic in C++ or other backend languages. To expose list of various types from C++ to QML, Qt provides several mechanisms that enable seamless integration between the two environments. These include exposing QLists of registered types and QAbstractItemModel. The most powerful and preferred method for exposing lists from C++ to QML is, or any other data set to QML, is by utilizing QAbstractItemModel. QAbstractItemModel is an abstract class in Qt that provides a standardized interface for working with structured data. By implementing a custom subclass of QAbstractItemModel, developers can expose a list of data records, as well as complex hierarchical data structures like lists, tables, and trees. Using QAbstractItemModel allows for more advanced features like sorting, filtering, and dynamic updates, making the QAbstractItemModel highly flexible and scalable. Using QAbstractItemModel, you can not only get the data, but also modify data by like a single record. Additionally, other ways of exposing data in case of change, like adding new records, changing or removing existing records, will reset the whole view in QML, which in other words means that each of the dynamically generated elements will be deleted and replaced with the new one, which is not really efficient, right? Especially when you have a lot of items in the views that need to be re-rendered again. Yeah, and in case of QAbstract item models, only the records associated with affected data will be changed, keeping performance on the top level. To implement a custom QAbstractItemModel class, developers need to subclass it and provide implementations for several virtual functions. These functions include row count, column count, data, role names. Yeah, and that's the most popular ones. The deriv class defines the structure and content of the model by implementing these functions according to the specific requirements of the data being presented. One of the key concepts in QAbstractItemModel approach is the notion of roles. Roles define the different aspects or properties of an item within the model. Each item can have multiple roles associated with it, and the roles are used to access and manipulate the data from QML. Finally, there is also possibility to expose a static list of data using a QList of register types as a Q property. By default, basic types like int, double, QString, and other Qt internal types are registered, but there is also a possibility to register your own classes in Q meta objects system. And then QList instances of these types can be directly exposed to QML using Q property. This approach is a preferred one when you have a static, non-changing list of elements. For example, list of languages supported by the application. In such case, it will be easier to use simple QList than implementing whole QAbstractItemModel for non-dynamic lists. Okay, so how do you display data coming from such models? You can do that by using the built-in view QML types such as list view, grid view, swap view, and many others. These types offer convenient ways to present data in the form of a list, table, tree, or the other way. Views require a model property to be set, and that's exactly what you will do to connect model and view. Do you remember how we used a repeater in one of the previous episodes? It's also using a model property. So here you could even set your own model module, model. Yeah, and in general, you will meet the use of list view and swipe view much more, as they are the simplest way to dynamically generate delegates. Okay, let's stop talking and jump into some coding. We'll continue improving the best audio player in the world. Previously, we created each song by ourselves as hard-coded. Audio info boxes were just like static. Now we can create dynamic playable playlists, which will provide song names and allow to remove or add audio in the playlist. We'll also get rid of multiple audio info boxes instances in QML, leaving only one to contain information only about currently played song. Yeah, so let's do this. To save us some time, I have done something already. Firstly, I converted player controller to be derived from QAbstractListModel, and it will be model containing our playlist. On the QML side, I prepared a panel which will contain our list of songs as a playlist. As you can see, I prepared a text sync playlist and a plus icon button. I also added everything to Qt add QML module command on CMake, so we don't have to worry about it. This is how it looks right now. Okay, so we will start by filling our model. So let's go to player controller, and here let's create private queue list, audio info pointers, audio list member. Let's add missing header. Okay, let's add it to source file. Now we need to implement virtual methods. Let's hover the base class name and press Alt Enter, and then select insert virtual methods. And as you can see, there's plenty of them. As we are using QAbstractListModel, which is based on QAbstractItemModel, some methods were already implemented, like for example column count, which in case of lists is not needed. We will implement data, row count, and role names functions. I also checked add virtual to function declaration and add override as well. We click OK. Yeah, and let's clean here. Okay, so firstly, role names define how particular fields of one record are named. We are going to need enumeration type for that, as role names are basically map of integers and strings. In case of QAbstractListModel row count, it simply returns how long the model is. And finally, data is for returning data using a specific row and given role. Okay, like I said, we are going to need some enumeration for roles. So let's define it right after public. Yeah, and then for each field in audio field, we need to define a separate role. So we write unknown values like that, audio title role, audio author name role, audio image source role, video source role, and audio source role as well. And notice that every unknown value has name of unknown as a suffix, so you won't confuse it with anything else. Yeah, and Qt provides some default roles. The last Qt defined role is Qt Qt user role. So let's make our first unknown value equal Qt user role plus 1, so it does not collide with Qt's existing roles. Okay, now let's go and implement virtual methods. Firstly, let's implement role names. Role names define how each role will be named in QML. We need to define it as a map of integers and strings. And for each unknown value, we'll just need to create a string equivalent. Just like this. And now row count. Row count basically tells us how many children rows with a given QModel index has. But yeah, that's the case for tree models. For lists, we can just ignore this parameter with QUnused macro. And then we can simply return length of our internal list of objects. Yeah, and now data function. First, we need to check if given QModel index is valid. If its row falls between 0 and at least length. And if it meets this condition, then let's get our entry from the list using our index row, and then let's create switch iterating over wanted role. We can autocomplete it using bulb. Next, we need to return appropriate value for each unknown value. each, just like that. And in case something was not valid, then we can just return empty Q variant, for example, using brackets. Yeah, now let's modify existing methods. Switching audio should be now fully controlled from C++, as now we have full access to sources of audios here. Everything is kept on C++, so let's remove current song index and also song can't. We'll remove those properties, their methods, signals, and fields. And now let's add a QProperty audio info, current song. It will point to the song currently being played. Let's generate missing fields. Next, we need to update existing methods to use pointers instead, but I forgot about definitions here. Let's remove them. Okay, let's start with switch to next song. We will use QListIndexOf, a method to determine current index of a song, and then we will change song as we did before, but with a use of setCurrentInfo function. So if our song index would exceed the size of the list, then we can just set it to the first song in the list using the mAudioList first method. And if it's not, then we will just pick the one with a higher index. Emit is not needed here anymore. Then let's do the same, but like in reverse or switch to previous song. I'm just sped it up. Finally, in set current song, we can call change audio source function directly, as we will keep paths to audios, and everything else in C++ now. So if it's not a null pointer, then we can simply pass its audio source, like from the current song, to be played, and otherwise we will stop media player, set source to invalid URL, and we will also set internal mPlaying to false, and we will emit playing changed signal. Yeah, now we need to make this playlist customizable, so let's add a function to add a song audio. Let's name it add audio, and it will take 5 arguments. 2 strings for audio title and author, and 3 URLs for audio source, cover image source, and cover video song, which will be invalid by default. Then we will also need a remove audio method that will remove song by a given index. Use Alt plus Enter to add definitions. 1, 2, yeah. Inside implementation of add audio, we'll construct a new audio info object as a pointer. We'll pass player controllers of this as a parent, and we will set all needed fields. We need to set title, author name, image source, audio source, and finally video source. Then if list is empty, then we will set it as a current song, like this. And finally, we can append it to our list of audio as our list of songs. Okay, so now if you want to insert or remove some data, then you need to notify all views connected to the model. We do this by firstly calling the begin signal and finally by emitting the end signal. In case of adding entries, we need to call begin insert rows. First argument here is parent, in which something will be inserted. So in our case, in case of list, it's plain QModel index. Then we specify on which indexes it will be inserted, which is simply the length of our list. So it's going to be m audio list length, and the same for the last argument. It's the last inserted index. As we are adding only one item, it's also going to be audio list length. Yeah, finally, we have to, after we are done with adding, we have to call and insert rows. Okay, and now let's implement removing. Firstly, we need to check if index falls in range from 0 included to list count excluded. If it meets the condition, then we need to check if the currently played song is not the removed one. And if it's currently playing song to remove, then we need to check if there is more songs in the list. If there is any other song, then we'll switch to the closest one, checking if current index allows that. So if it's not 0, then we move to previous one. And if it's 0, then we will move to the last one. Okay, and finally, if there is only one song in the list and we will remove it, then we need to nullify the current song, so it's not kept. And yeah, then we can just use QLists remove add methods to quickly get rid of unwanted audio, and then we can call delete later to clear the memory. Now we need to somehow change the song when it's pressed. We could just set current song player control from QML, but we don't have direct access to our internal model list. So we will use song indexes for identifying them. To do so, we will need to add a function to switch to given audio by given index. Let's name it switch switch to audio by index. Then quick Alt Enter, and we can implement it. As previously, we need to check if in the index is in the correct range, so let's copy it. If it is, then you can simply invoke set current song, passing audio from list at given index, and then we are good to go. Okay, functions seem to be ready, but the model is empty, right? We need to put some data, so let's do that in constructor for now. I will use add audio method to add the very same audios as we had before in QML. To save you time, I will skip this part. Okay, this is how it looks right now. Notice that we have to use full paths with a use of QRC here. Yeah, and that should be it. Let's implement some more UI. So we go to playlist QML and I will show you how it looks right now. Okay, so as you can see here, I defined some animations using behavior on X. It's a nice QL mechanism which allows you to implement animation whenever given property changes. In our case, I also defined a boolean property hidden, which is then used to change X property in main QML file here. It will move nicely when it's required or hide the panel outside of the scene when it's not required. Inside playlist panel, there's also playlist text and add button on the bottom. But besides that, that's just an empty rectangle and it should contain list of songs, right? So let's fill it using a list view. Let's name it. List view is a simple way to display a list of items using given model. Let's make it anchored to playlist text and add a button. Let's also make it fill parent horizontally. And let's give it some margins of 20. Then we wanted to clip the children, so children do not overflow the list. Next, we need to declare on which model we are basing. We need to import our module with the model first. We learned about that in the previous episodes. So player controller. Yeah, and then we can pass player controller as a model. Then let's specify some spacing between items. So they won't be stick to each other. And next we need to define how single playlist entry looks like. We can do it defining delegate property. Let's make it based on rectangle. Let's give it an ID. Let's make it list views width and height of 50. We make it in the same color as our main container from QML. It was like that. And then we declare here required properties to keep data from model. They will be the same as in role names C++ function. So let's take a look to remind ourselves. Let's make the first one, and then I will just copy and paste, and then adjust types and names to reflect what we have on C++. And in addition, I will also declare required property of type integer. It's going to be called index. It will be filled by the list view itself. Okay, it should be in the delegate, not in a list view, because every delegate has those things. Yeah, index will be providing info about the index of our delegate. Okay, so we have everything. Our delegate will consist of a column containing a song title text and author name. On the right, there will be a trash icon to remove audio from the playlist. We'll also add a mouse area that will fill parent, allowing to switch song. And yeah, then let's anchor remove button to the right and vertical center and give it right margin 30. No, 5. The width will be 30, height will be 30. And we need to set the path to the trash icon. Yeah, and finally, the functionality. In onClick slot, we'll just invoke player controller remove audio. and we'll use delegates index as parameter. Then let's anchor column to its parent top, parents left, and to the left of the trash icon. And let's set margins. Let's also define spacing. And now let's create text items to display actual values of audio title and author name. We'll give it the same width equal to text column width. And we'll also make them elidable using elide property. Elidable means that such a text will be truncated in case it's too long to fit a given width. We'll also enhance our text by using font size mode, text.fit, and minimum pixel size 10. Why would we do that? Well, some song names may be too long to be displayed in the delegate. Defining font size mode and minimal font size will adjust font size to make our text always fit given width until a minimum pixel size is reached. In that case, our text will alight on the right as we defined. So let's also give the text a white color, as our app has dark UI. And we also need to add some value to text. So let's set it to delegate audio title. Then I will define some default pixel size, 14, and the boldness. Okay, I will give the same properties for the second item. Except this one will be smaller, grayer, and we will have the other text property, and we have smaller pixel size and will not be bold. Yeah, so finally we need to make audio playable by changing the currently played song. So in mouse area, we will need to add onClicked, and let's invoke here player controller switch to audio by index, and let's pass the index here. Then on the bottom of the list, I added this plus icon. Let's implement this feature. For now, it will always add the same song, just to demonstrate how inserting works. We call add audio, and the song will be named Reprezentuje biedę, authored by Rychupeja. Sorry, I'm Polish. Yeah, there's MP3 I prepared earlier, and some image source for the cover. It's the same as for the third song. Yeah, let's check it. Okay, the list is here. The images seem a little bit too stretched, but don't worry, we will fix this. Let's test the list now. Okay, it's scrollable, interactive. You can add new songs to the playlist. However, removing song is not working, and why is that? Let's go to the player controller and debug that in remove audio function. Before removing, let's print all entries using a loop like this. Then we will print some separator, and after removing the audio, let's check the content of the songs list again. Okay, let's try the app again. Let's maybe see the output. Okay, let's add this song. Now let's remove one. Okay, as you can see, the song was removed, but it was not really reflected on the UI side. Why? Well, that's because I intentionally forgot about one needed thing. To make view aware of the model change, we need to call begin remove rows, which notifies view that some items will be removed, and end remove rows, indicating that removing process has been finished. Let's add them. Let's add them, maybe the first one here. So begin remove rows. The first argument is, like in case of begin insert rows, empty QModel index. Last, then we have to provide index of first removed item, which in our case is just the index parameter. And lastly, we have an end index of removed item, which in our case is also an index argument, as we are removing only one item. Yeah, and after that we call end remove rows. Yeah, let's also get rid of those dummy debug statements. Okay. Oh, okay. Now let's go to image bottom QML to fix that stretching effect. Let's add property fill mode equal to image preserve aspect fit. This will prevent stretching of trash buttons. Yeah, it should be it. Let's build. Okay. Final check. We have our list. Trash icons are okay. Let's add something. Okay, removing works. Entry was removed, and you could even clear the list. However, song info box is not displayed at all. We need to adjust something. We need to modify audio info box to remove old invocation of change audio source, as now it's fully controlled from C++ side. It's not needed. Then component uncompleted is not needed as well. And then we can also get rid of this info provider property, as now everything is stored in current song property of player controller. So we need to replace all info provider references with player controller dot current song. Replace all. Okay. Yeah, but first we need to check if current song is not null. We can do it by double negation. Thanks to this, we convert object to Boolean value. If it's true, then let's use this image source property, and otherwise let's use some default value. Yeah, and let's do the same for the other properties. Okay. Additionally, we need to update visible property. Now we will make it visible only when current song is not null. So it will be equal to double negation player controller dot current song. Now in main QML, we need to get rid of multiple audio info box instances. We will leave one. It does not need info provider as it was removed. Let's change the ID. And then we can disable those controls to play the song on the bottom if there is no current song selected. We will do that by using enable property on row, and it's going to be equal to double negation of player controller current song. So if it's disabled, then no mouse input will be passed to the buttons. Okay. Additionally, to indicate that they are disabled, we'll bind opacity property to be um, um, if it's enabled, it's going to be 1, and otherwise it's going to be like 30%. Yeah, and let's build it. As you can see, it's working now. We have like the song in the middle. You can freely switch them, add them, um, yeah, switch. Yeah, but third song does not have a video. This is because we do not actually play it anywhere. We need to go back to audio info box to fix that. So we need here to play video whenever the source change. So let's use for that, let's use on source change slot. Then inside we check if source is not empty. If yes, then we play the player, and otherwise we stop it. Okay, I hope that it's going to be the final build. Okay, let's check it again. Yeah, there's the video. Okay, so it's all working as expected. We do not longer have a dummy list on QML side that we created statically, that was hard-coded on QML side in the code. Now we have something more dynamic. That's basically how you make QML display set of data from C++. And we'll extend this example in the next episode, which will be about accessing data from Q Network Access Manager from REST API, and it's going to be very cool, and it's going to be the final technical episode. The model that we implemented now, it also has a feature of adding and removing entries. The things that I showed you today is only like a tip of the iceberg. The topic of C++ models is huge. They are really, really powerful and convenient in use. And for example, I did not show you how to edit single data record, how to insert a new record in the middle of a model, how to create tables, trees, and I did not show you many more. This is a basic course, and that's what we do here. We learn about the fundamentals. I strongly encourage you to follow us on LinkedIn, to subscribe to our YouTube channel, to like the video, to comment under this video, to follow us on LinkedIn, to watch our podcast named Qt Talk. All the links, everything, all the information about us are in the comments. Thank you for the present. See you in the next one.